Welcome to all. I am Vibhuti CP from KG Somaya College, Koparga. Here we are going to learn the CHO 150 course of Organic Chemistry of MSc first year student. Here we are going to learn the different rearrangement reactions. Earlier we learned some reaction having the isocyanide intermediates. Today we are going to learn the next rearrangement reaction, that is called as a Baeyer Villiger oxidation rearrangement reaction. Here, before to start the Baeyer Villiger oxidation reaction, we must know what is the oxidation. Oxidation is nothing but the process in which the addition of oxygen takes place or removal of hydrogen takes place. And also, what is the oxidation? The oxidation is also the loss of electron and increase in oxidation number. Okay, in organic point of view, what is the oxidation? Oxidation is the addition of oxygen and the removal of hydrogen. And in inorganic point of view, the oxidation is a loss of electron and the increase in oxidation number. Let me learn some examples here. This ethanol which get converted to the ethanol, that is the aldehyde, this is due to the loss of hydrogen. Okay, and this is called as a oxidation reaction. We would need to use the oxidizing reagent for the oxidation reaction. Here in this example we need the oxidizing agent for conversion of alcohol to the aldehyde. These oxidizing agents are maybe potassium dichromate compound solution acidified with the dilute H2SO4. Also for this oxidation we use the cheminophore reagent. Let me learn our reaction, that is a Baeyer Villiger oxidation reaction. Then let me learn the definition. The transformation of ketone into the ester and also the cyclic ketone into the lactone or hydroxy acid by using a peroxy acid is known as a Baeyer Villiger oxidation reaction. This is firstly discovered as 1899 by the Baeyer and the Villiger. A wide range of oxidizing agent can be used to perform the Baeyer Villiger oxidation reaction. The reagent typically used to carry out this rearrangement are the MCPBA, that is metachloroperbenzoic acid, or the peracetic acid, etc. The reactive and the strain ketone react with the hydrogen peroxide to form a lactone. Here this Baeyer Villiger reaction also done with the aldehyde, but it gives the acid, and here the formation of the acid from the aldehyde has the different reagents and the number of reactions are there, but the conversion of ketone into the cyclic into the hydroxy acids and the cyclic ketone into the lactones has no any other reaction. That's why here for the conversion of ketone into the ester and also from cyclic ketone to the lactone, the Baeyer Villiger reaction is very important. Let me learn their mechanism. The mechanism of Baeyer Villiger rearrangement is not clear. However, it is believed the reaction proceed as follow. Here what happened in this reaction, this ketone which on reaction with the peracid, that is MCPBA, then here this is the acid, that's why here the oxygen which has a lone pair which abstract this hydrogen and there is a formation of OH. There by the donation of lone pair of the oxygen to this hydrogen, there is a formation of positive charge on this oxygen. Then the peracid which is reacted with these compound, this oxygen which has the lone pair here, what happen? This donates an electron to the carbon, which is a carbonyl carbon. Then there is a formation of like this compound. Okay, here this can be write in this manner also, that is OH C plus C plus. Okay, and that's why here this positively charged carbon which is attacked by this oxygen, there is a formation of like this product adduct. Okay, then what happened here? This OH, by the removal of H plus, what happened here? This here this H plus is from this here, we get removed and form this type of the adduct. Then this OH bond is shifted to here, you can see in this arrow, this bond is shifted to here, and then what happened? This R1 is rearranged to the oxygen. This is rearranged to this oxygen, and the oxygen bond is going to break, and there is a formation of this type of product, that is R1 C double bond O R2, that is a ester, and plus the remaining compound are what? R3 OH C double bond O and O minus. Here this H plus is attacked to here, and there is a formation of OH compound, acid and the ester. Okay, this is the mechanism of this reaction. Okay, here what happened here? The ketone which on acidification, their OH group is attacked, then this oxygen has a positive charge, that's why the double bond is shifted to the oxygen and carbon become positively charged. Then the per acid, oxygen of the per acid is attacked to this carbonyl carbon, and then there is a formation of like this compound. Then at the same time this OH bond is going to break, and then this R group is rearranged to this oxygen, and there is a breaking of oxygen bond, and here we get the product. Okay, this is the mechanism of the Baeyer Villiger reaction. Here this initial protonation of the carbonyl oxygen is followed by the addition of the per acid to yield an adduct which undergo a rearrangement where the R group is migrated to the electron deficient oxygen. What happened here? This R group must be migrated to the electron deficient oxygen. Okay, the silent point are retention of stereochemistry by the migrating group. The migration concerted with the departure of leaving group and increased migratory aptitude of the group possessing a greater electron donating power. The retention of stereochemistry by the migrating group takes place. That means if the carbonyl attached to the stereocarbon or chirally active carbon, then the product which we form, which is gives the retention of stereochemistry. The migration is concerned with a departure of a leaving group. The concerted step is a rate determining step. The migrating group which greater electron donating power have, the migrating group must have what? The greater electron donating power that correspond to the greater migrating aptitude. That means what? The group which has the greater electron donating power, that means the any group which attach to the electron donating group, that is a CH3 group or tertiary butyl compounds, that time this group is migrated. The migration is favored when the migrating group is anti-periplanar to the oxygen bond of the leaving group. That means what? Here the what happened, the migrating group is must be what, the anti-periplanar to the oxygen bond. That means this R group, it must be trans. We learn already in the which reaction, Curtis reaction and the Schmidt reaction. The migrating group is must be what, the opposite, trans to the oxygen bond, then only this group can be migrated. Okay, this is known as a primary stereoelectronic effect. Here let me learn the migrating aptitude. The order of preference for migrating among alkyl group is what? First of all, the tertiary. Here must what happen? This electron donating group has the highest migratory aptitude than the electron withdrawing group. And if the number of electron donating group is present, that time here the preference will be first the tertiary, secondary carbon, then primary carbon, and last one is the methyl. The aryl group migrate in a preference to a methyl and a primary alkyl group. In aryl series, the migration is facilitated by electron para position. Next we learn the applications of the Baeyer Villiger reaction. This Baeyer Villiger oxidation has a greater synthesis alkalinity as the permits the transformation of the ketone into the ester. An oxygen atom is inserted next to the carbonyl group. This reaction is applicable to the both, that is for acyclic ketone and also the cyclic ketone. The oxidation of a cyclic ketone occur the ring expansion and form a lactone. Here in this example you can see this is the cyclohexanone which is on Baeyer Villiger reaction, we get the lactone. Next application is the Baeyer Villiger oxidation is also possible by the action of enzymes. That means in this reaction this cyclohexanone which is treated with the cyclohexanone oxygenase enzyme, then here we get the product, that is the lactone. Next is the aldehydes also undergo the Baeyer Villiger oxidation to usually gives the carboxylic acid. This reaction involves either the migration of the hydrogen or fragmentation of the intermediate. Let me learn some examples. This is a ketone which on using different per acid. Here we use the H2O2 as a per acid, we get the 84% of the product. But if we take the substituted, that time we gives here the 69% of the lactone, and here this product, if the substituent which is to the meta position, then we get the maximum, that is 100% of the lactone. Okay, here these are some examples of the compound or the reactions of the Baeyer Villiger reaction. First here benzophenone which on Baeyer Villiger reacted with the per acid, we get this type of product. If here in this case what happened here, this CH3 is electron donating group which is the substituent, that's why here the ester or oxygen which is added to this position. Okay, here in this case here what happened, OCH3 group is attached to here, this is also electron donating group, and that's why here migratory aptitude towards what, this position. Okay, next this is here, this is not happen here. In this position NO2 group is electron what, withdrawing group, and that's why here this migrating aptitude or this oxygen is attached to this position, not to Na2 benzene. Okay, here these are some also another examples. Here this is on Baeyer Villiger reaction, there are the two possibility of the addition of the oxygen, but here both have in the same, that's why we can write the any position. Next here this is the benzophenone which on reaction with the per acid H2O2, where here we get the product that is called as a caprolactam. Here this is here at this position there is a more substituted carbon is there, that's why oxygen is attached to this. Here this is the more substituted, okay, compound. Yeah, this is the substituted compound. Here this is the two COCO group is there, that's why oxygen is attached to here. At this position this is a more substituted carbon, and that's why here this oxygen is attached near to this substituted organ. Migratory aptitude is over here. Okay, then this is about the Baeyer Villiger reaction. Thank you very much for watching this lecture. Search more example related to the Baeyer Villiger reaction and solve it yourself. Then only you can understood what is the Baeyer Villiger reaction and how to solve, how to draw their mechanism. Thank you very much for watching this lecture.